Hey everybody, here is a video with a couple more examples of how to use our definition to get slope, our formula if you will, for slope of the tangent. So the question is typically, find the equation of the tangent line tangent to this curve at this particular point. So we're going to go ahead and I can do this both ways. So I'll do it the x to a method. So the slope is going to be the limit as x approaches a. But for this example, our a is actually 3. I'm going to go ahead and put that in. Of f of x, which is 3 over x, minus f of a, which is 1, all over x minus a. So that should be your setup. Okay, so if you don't have the basic rule written down, here I'll just write it over here. The slope is going to be the limit as x goes to a, f of x minus f of a, all over x minus a. This is sort of definition number 1. Okay, so we're going to go ahead and simplify. We've done ones like this before where you have the complex fractions and the strategy was to combine them. So get a common denominator and just start simplifying and see what happens from there. So if I do that, this is going to be 3 over x, no big deal. And then the 1, I'm going to have to do x over x, all over x minus 3. We'll clean that up. Limit as x goes to 3. This is going to be 3 minus x over x minus 3. Well, it's close. This is 3 minus x and this is x minus 3. Hopefully you realize it's just a factor of -1 to sort of switch them back. So if I want to cancel these out, I can do that, but I'm going to have a factor of -1 to in order for that to actually work. Okay, if I redistribute, then I would get the 3 minus x. So if I do that, that's going to leave me with -1 over x as x goes to 3, which then is going to be -1/3. So my slope is -1/3, and if I need the equation of the tangent line, well, that's going to be y minus 1 equals -1/3 x minus 3, and there is your tangent line. So this line is tangent to that curve at this point. Alright, let's try it with the other method just so you can see. The other method, I'll write it up here, is the limit as h goes to 0 of f of a plus h minus f of a all over h. This was definition 2, or they might have called it formula 1, whatever the book calls it. It doesn't really matter. You just need to know there's 2 different ways to do it. Okay, and our function was 3 over x, and our point was 3, 1. Okay, let's substitute in. So my slope is going to be the limit as h goes to 0. F of a plus h is the same as f of 3 plus h. So that's going to be 3 over 3 plus h. Right? Replace x with whatever's in here. Replace it with a plus h, but a is 3. So I'm going to replace it with 3 plus h. Minus f of a, which is 1, all over h. So this one's kind of the same strategy, and I still need a common denominator. In some ways, the other one might have seemed a little simpler, but the actual steps are virtually identical for this particular one. So let's get a common denominator. This is going to be 3 over 3 plus h minus 3 plus h over 3 plus h all over h. So that's where the 1, I just rewrote the 1 like that so I can get a common denominator. And that's going to be 3 minus the quantity, 3 plus h, be careful there, all over 3 plus h, all over h. Hopefully you notice here the 3's are going to cancel, but this negative is actually distributed to the h, so when I go to cancel these out, I again have a -1. Okay, don't forget to distribute. So this becomes the limit as h goes to 0 of -1 over 3 plus h. And as h goes to 0, that goes to 0, -1/3, which is the same slope as before. Okay, so there's your example for that. Actually, what would be good to do? Why don't we do it where it's not at a particular point? Okay, so watch this. I'm going to do the same function, 3 over x, but I'm going to do at x equals a. So this will get me sort of my formula for slope for any point, any value a. So I'll do the x to a method for this one. So I'll do the limit as x approaches actually a of f of x, which is 3 over x, minus f of a. Well, f of a is just 3 over a, right? Literally, if I'm following this, this says to take your function, f of x, then subtract the same function but evaluate it at a. So I'm going to subtract the same function but evaluate it at a, all over x minus a. So the strategy, the algebra, is basically the same, but I got to do it generic. So this is x goes to a, and this is going to be, let's see. So this one, this is going to need, you know, a over a, and this is going to need x over x in order to get a common denominator, right? So that turns into 3a over xa minus 3x over ax, all over x minus a. Clean that up. So I have 3a minus 3x over ax, all over x minus a. And you gotta be a little careful here. You can almost see it kind of hiding in there, right? You see that you have an a term minus an x term, but I need it the other way around. So I'm going to factor out the -1, but I also have the 3 here. So I'm actually going to factor out a -3 in order to make it, I know it's got to look like this. The whole point is to get the denominator, you know, factored out so that you can simplify, so you can actually put in the value. So this is going to be -3 x minus a, right, over ax, all over x minus a. Redistribute if you're not seeing it. -3 times x is -3x. -3 times -a is +3a. I just switched it around so that this would look better. Okay, so that's going to be the limit as x goes to a of -3 over ax, but as x goes to a, this becomes -3 over a times a, which is -3 over a squared. This is going to represent the slope for any point, any a value for this curve, the slope of the curve at any particular a value. So if a is, say, 3, right? If a is 3, look what happens. Let a equal 3. You're going to get -3 over 9, which is -1/3, which is what we got the other 2 times. Okay? So that's pretty much all the way through, every possible way you could see it. And it all comes back to knowing how to manipulate the 2 versions. Okay, so I hope that helps. If you have any questions, be sure and let me know, and I will see you guys later.